Alright, hi guys. This is a quick video to help you with your assignment for today. So what we're going to start talking about, we're jumping back into trigonometry, and we're going to work on finding those 6 trigonometric values: sine, cosine, tangent, secant, cosecant, and cotangent. And we want to be able to do that no matter what information we're given. So we're going to take ourselves off of the unit circle a little bit and explore some different ways to find these values. So you're not necessarily going to be glued to your unit circle for this. We're going to have to figure it out with just some right triangle information. So the first thing that we want to do is find those 6 trig values if we're just given a right triangle. Okay, so here's the triangle, and they've given us 2 sides. One is 6 and one is 8. When we think about this here, I want to first find the sine of theta. We don't actually know what theta is at the moment, but we want to figure out what's the sine. Well, if you remember from SOHCAHTOA, sine is opposite over the hypotenuse. All right. So from theta, 6 would be the opposite side. The hypotenuse is always across from the right angle. And then 8 would be the side that is adjacent. So when I look at this here, we'll just make this line up. We're going to need to find both the opposite side and the hypotenuse to come up with the sine. Well, I don't have the hypotenuse yet, right? So if I'm going to find the hypotenuse, then I want to use what I know about right triangles, and that would be, I can use the Pythagorean theorem to find that third missing side. So 6 squared plus 8 squared has to equal c squared. 36 plus 64 is equal to c squared, or c squared equals 100, which then tells me c is equal to 10. Excuse me. So if c is equal to 10, that's the hypotenuse value. You might also recognize this is a Pythagorean triple. These side lengths come from a 3, 4, 5 right triangle. This is just a multiple of that, 6, 8, and 10. Okay, so now that I know all 3 sides of the triangle, that's step 1 really. Then I can go ahead and set up my different functions. Well, sine is opposite over hypotenuse, so in this case it would be 6 over 10 or 3 over 5. All right, so that is the first function value. Then I want to go and find the cosine of theta, which is the adjacent side over the hypotenuse. So in this case here, the adjacent side is 8 and the hypotenuse is 10, so we get 4/5. All right, and then to find the tangent, we're going to need the opposite over the adjacent. So here we would have 6 over 8 or 3 over 4. So there are your first 3 function values for the first 3 trig functions. And then remember, secant, cosecant, and cotangent are just the reciprocal of these. So for the sine, if I want to find the cosecant of theta, it's going to be the hypotenuse over the opposite, which would be 5 over 3. For the secant of theta, it's going to be the opposite of cosine, the reciprocal of cosine, so it's hypotenuse over adjacent, which would be 5 over 4. So I'm just reciprocating that, right? And for cosecant, I just reciprocated the sine. And then last, for the cotangent of theta, it's going to be the reciprocal of tangent, so adjacent, over the opposite, which is 4/3. All right, so they're all 6 trig values. Use your trig reference sheet to help you with the SOHCAHTOA piece. And it says, I think somewhere on that paper, keep common past trig with SOHCAHTOA. If you remember SOHCAHTOA, then really you can do any of the different functions. You can derive any of the different things that we're talking about, just knowing that little bit of information. All right. So that's your first example. If you're given a right triangle, first do Pythagorean theorem to find the missing side, and then use SOHCAHTOA to set up your function values. So let's look at another example here where we're given a function value this time, and just by knowing that one, we want to find the other 6. Okay. There can be multiple triangles, multiple similar triangles that are created that have the same function values. They just might be a multiple of each other. So for example, these function values we got here, sine, cosine, tangent, etc., they came from a triangle that had side lengths 6, 8, and 10. We would have gotten the exact same function values if these side lengths were 3, 4, and 5. All right. So it might be 2 different triangles give the same function values, but that's because all of these function values are the ratio compared to where your angle is. So when we are given a function value, we don't know that this is exactly the triangle it would create, but it would give us one option. All right. So the tangent of theta is equal to 3. That's the very beginning here. And so the first thing that I have to do is I have to sketch a right triangle. It can look like anything. And I have to give theta a position. It can't be the 90-degree angle, but it could be in either of those other 2 places. I'm going to place it in the bottom left. Truly doesn't matter where you put it. You'll end up with the same values when you're done. And so for tangent of theta, we know that tangent is, we just said, opposite over adjacent, right? Well, 3 isn't currently a fraction, but I could turn it into a fraction by doing 3 over 1. So that tells me that the opposite side must be 3. So from theta, I'm going to go opposite. That must be 3. And then the adjacent side has to be 1. So here, the adjacent side is 1. And then again, just like we did up above, we're going to use Pythagorean theorem to find the missing side here. So a squared plus b squared equals c squared. 1 squared plus 3 squared is equal to c squared. Remember, c is always the hypotenuse. So 1 plus 9 is equal to c squared, or 10 is equal to c squared. And taking the square root of that, c is equal to the square root of 10. That doesn't simplify anything to anything. Sorry, 10 is not a perfect square, so it doesn't simplify down nicely. We want to leave those exact, so I'm going to leave it as the square root of 10. And just remember, when we do our calculations, we might have to rationalize some denominators here. So we already know tangent, but now we can go and find the sine of theta. Well, again, remember, sine is opposite over hypotenuse. So in this case, it's 3 over the square root of 10. And I have to rationalize that by doing the square root of 10 over the square root of 10 and multiplying. So 3 square roots of 10 over 10. The cosine of theta is the adjacent over the hypotenuse. So we're going to get 1 over the square root of 10, which again, if we rationalize, is going to become the square root of 10 over 10. Tangent, we already know, is 3. And then to find the other 6, we're just taking the reciprocals, all right? So let me get rid of this really quick so I have some more space. So sine gives me cosecant. And I'm going to take the reciprocal from the very original one that I set up. So it's going to be the square root of 10 over 3. I don't have to rationalize because there's no radical in my denominator. Cosine gives me secant. And again, I'm going to take the reciprocal of the original. So square root of 10 over 1, which is just square root of 10. And then cotangent comes from tangent. The reciprocal of 3 over 1 is 1/3. And there are your 6 trig values. All right, so again, similar steps. We're going to look at the function value, figure out which two sides of the triangle we know because of this function, and then we're going to, sorry, my cat is scaling the chair right now if you can hear that. And then we're going to set up a right triangle and find those same function values, exactly like we did when we're given the triangle to start with. All right, and one last thing for today is when we're given a point on the graph. So here is my sketch of the graph, and -5, -2 is going to land us in quadrant 3 somewhere. It doesn't have to be perfect. So that is my angle. That's the theta that you're looking at, right? But when we do this, we want to create what's called a reference triangle. That's what those two triangles are up above. And to do that, we're going to make an acute right triangle. We're going to look at the acute angle and turn it into a right triangle here. So I'm going to take the end of this point, and I'm always going to connect it to the x-axis to make the right triangle. So no matter where you are, if you were over here, you would bring it down to connect to the x-axis. If you were over here, you would bring it down to connect to the x-axis. If we were in quadrant 4, we would bring it up to connect to the x-axis. And theta, your reference angle, which we'll call theta prime, so theta with a tick mark, is going to be nearest to the origin, okay? So this is my reference triangle that I'm working with. And because this is a point, x, y, we know two different lengths. We know that the x direction gave us -5, and that the y direction gave us -2. And look, I have a little right angle right there. So I'm going to guess you can already imagine what's coming next. Now that we have two sides of the right triangle, we have to find the third. So your steps are exactly the same as the ones up above. Now you just have, you just had to graph your triangle first. And the negative values really just tell us what quadrant we're going to be landing in, okay? So when I start to do this here, I have, again, -5a squared plus b squared equals c squared. So 25 plus 4 equals c squared, or c squared equals 29. And then taking the square root of that, I find what c is. Your hypotenuse is always going to be positive, all right? Because that piece is just the distance. But the legs of the triangle, the -5 here and the -2 here, those could be negative. So now you have all three sides of your right triangle. From theta, which is centered in the corner, this is my opposite, my adjacent, and my hypotenuse, all right? And then you can go ahead, just like we did up above, here, and at the very first one, and find sine, cosine, tangent, cosecant, secant, and cotangent by using SOHCAHTOA, all right? So go ahead and give your assignment